Welcome to Rges Pre-Algebra, Lesson 16A. Today we're going to be talking about square roots. Now, to square something, let's say I say, well, let's not say that one. Let's say I say 4 squared. That means I'm going to take the base, 4, and I'm going to multiply it by itself as many times as the exponent. So this would equal 4 times 4, or 16. Now, square roots undo squares, meaning they are asking, let's say I'm saying, what is the square root of 16? I'm saying, what number multiplied by itself 2 times will equal 16? This is the radical sign, and this number under the radical sign is called the radicand. For a square root, if there's no number right there, we assume that means square root. But I could say cubed root. What is the cubed root of 8? And then I'm saying what number multiplied by itself 3 times will equal 8. The same number multiplied by itself 3 times. And if you could think that through, the answer would be 2, because 2 times 2 is 4, times 2 is 8. So if I knew that 2 to the third equals 8, so my familiarity with powers will help me as I'm working on roots. Now, let's talk a little more. So again, my terms, the number under the square root under the root is called the radicand. The number up here is called the index, indicating whether it's a square root, cubed root, etc. And the sign itself is called the radical sign. Radical. Okay. Now, when I think of square roots, let's go back to square root of 16. There are always 2 answers to a square root. Why? Because a positive 4 times itself would equal 16, but also a negative 4 times itself would equal 16. So this has 2 answers, positive 4 and negative 4. When we talk about the principal square root, we're talking about the positive 4. Now, a square root can generate either a rational answer, that means it would go in evenly, or it can be going by a ratio, a rational number, remember, either something that can be written as a fraction, or a terminating decimal, or a repeating decimal, like 1/3 would be the repeating decimal, 0.333, right? And let's see, what else would I say? Rational number, of course, an integer, okay, a terminating decimal, like that. All of these are rational numbers. Or an irrational number, meaning it produces, if I use the calculator, a decimal that does not form a repeating pattern, like something like a 3.1416897. I started with pi, but then just changed it. Okay, so anything like that where we just go on and no repetition. So that would be irrational. Now we're going to focus with our square roots on rational numbers. So when you get down to something like, if I say the square root of 64, they're going to ask you to write the principal root. So rather than writing plus or minus, go ahead and write only the positive answer, unless you have something like that. And then that will indicate the negative answer. Now, I will say that there are rules in this book are not always what you'll find in every book, okay? But here they're just asking to do the positive. If there's no sign in front, just write the positive. If there's a negative in front, write the negative. If there's a positive and negative in front, then write the positive and negative. What times what equals 25, and that would be 5. And so that's the way they want you to format that. If you had something that had both the numerator and the denominator, you would simply say, what is the square root of 4? What times what equals 4? And what is the square root of 9? What times what equals 9? And because there's no sign here, there's no sign here. It'll represent the positive. So again, you determine whether or not it's rational or not by whether or not it goes in evenly. So let me say square root of 77. Can I think of a number times itself that would equal 77? And I can't, let's say 6 times 6 is 36. 8 times 8 is 64. 9 times 9 is 81. So we have 64. We have 81, and this is between there, and so there's no whole number. So I would just say if it's not a whole number, you're going to be assuming it's irrational. Even though it could be a decimal, but it's going to have to have a decimal part here if it were. So this is going to be an irrational number. Okay, so that should get you through, let me think, most of the answers. There's some things in the book and the sharpening skills I wanted to talk over together. The sharpening skills 1 through 10. It says true or false. The principal square root of 9 is 3. Is negative 3. Is the principal square root of 9 the principal square root? Would it be negative 3? And the answer is no, false. It would be positive 3. Why? Because the principal root always means the positive. I'm trying to write a question mark up there. All right, number 2. The square root of, this is a good question, x squared. What is the square root of x squared? Would it be x? And the answer is yes, because x times x is x squared. So that's true. Number 3. The number 3/8 is an irrational number, and if we recall, what is the decimal equivalent to 3/8? If you don't remember it, you would take 3 and divide it by 8, and that would be 3, 24, 60. Recall how we did this? 7 would be 56. And that would be 40 and 375. And so it does go in evenly as a decimal. So they're asking, is 3/8 an irrational number? And it's false. 3/8 is a rational number. You might want to go back and review these fractions to decimal equivalents. Number 4. Actually, I've been labeling these wrong. I've been going straight down. So this one's 3. And this one was 5. Sorry. And 7. It says in the 4th root of 16 here, the number 4 is called the radicand. No, that's called the index, so that would be false. And the square root of 25 is a rational number? Absolutely. It's equal to 5, and all integers are rational numbers. Yeah, so that would be true. Let's go back and get the evens. Number 2. The number 11 in the square root of 11 is a surd. I did not introduce that, nor do I care that you know that. I've never heard that expression before. But if the answer's irrational, this is a surd. So it is true, but I'm not interested in that. Number 4. The square root of y to the 4th. That's a good question. Okay. What must I multiply? You probably don't quite know this. You'd have to think about it a minute. Okay. But what do I have to multiply by itself 2 times in order to get y to the 4th? Well, y to the 4th is y times y times y times y. And if I broke it into groups of 2, I would have to multiply y times y. And y times y is y squared. So if I took y squared times y squared, it would be represented by this, and I'd have y to the 4th. So that's also true. Number 6. The cube root of 27 is 3. They're asking, is that true or false? So there's the cube root of 27. So that means I would have to take 3 times 3 times 3. Does that equal 27? Well, 3 times 3 is 9, and 9 times 3 is 27. Yes, that's true. And finally, well, let's see, 2 more. Number 8, all positive numbers have 2 square roots. That's true. Okay, all positive numbers. I forgot to make that distinction earlier because I didn't talk to you about the idea that we could not take a square root of a negative number. We'll visit back to that in a minute. Okay, so the question again, all positive numbers have 2 square roots. That's true. For instance, there's a square root of a positive number, and its answer is 2 square roots. A positive 6, because 6 times 6 is 36, and a negative 6. Now again, when they're asking this on a problem, they're asking you to only identify the positive, the principal square root. But in reality, there are 2 square roots for every positive square root. Okay. And number 10, the square root of 100 is an irrational number. Well, what is the square root of 100? What times itself will equal 100? The answer is 10, plus or minus, right? 10, or if we're only doing the principal square root, which is what they're asking for, usually, it'll be like that, and that is definitely a rational number, not irrational, so this would be false. Okay, so you should have no problem doing the evaluation, and the last section on the sharpening skills is simply more of what the chapter was about. So you should have no problem there. Okay, I hope you have a great week, and we'll see you soon, God willing.